Okay, so on Wednesday, when Mr. Stingo was here, he went through regular expressions. So regular expressions are a way to describe a certain pattern that we're trying to find in text. So there was some confusion. Some students emailed me asking me, is this only for user input? Is this only for this? Regular expressions are just a way to identify patterns in text. What you use that text for or what you use that pattern for is up to you. Many different users. You can validate user input. You can also scan through documents and find, for example, license plates, car license plates in a document. Maybe it's a police report or something like that, and you need to find certain files that contain that specific license plate format. So if you're looking at the license plate format for Gauteng number plates, it's 2 letters, 2 numbers, 2 letters. And specifically, the letters cannot be a vowel. So you could write a regular expression to find that, and then you can find all references of license plates in any sort of documents like that. So it's not just for a single use, it's a very wide range of uses, and like I said, there's a lot of different things regular expressions can be used for, and it's very complex. It can get very complex. You can keep it very simple, but it can get very complex as well. So the main important thing about regular expressions is the syntax for a regular expression. You have something called character classes, and you have that square bracket notation indicating that you want something at a certain position. Character class is just basically a shorthand for writing out a square bracket notation with something inside of it. What's very important to note here, and that I'll point out, is if you look at /s, lowercase s, that is your white space. So there is a tab, carriage return, line feed, n is line feed. Then x0b is a 0 with space, that's a special one. And then /f is the feed character, and then R is the carriage return. Now, if you're wondering about what do those things mean, like line feed and carriage return, it actually goes back to working with typewriters. And with a typewriter, you type, and you go ding, and then it would move to the starting position again. That's a carriage return. That's the carriage returning to the beginning. That's why it's named like that. A lot of things that are named as the way they are now is because of something that happened physically, which we try to emulate digitally. Files and folders was a big filing cabinet where you had a big filing cabinet with folders inside. Instead of it, we have files. That's how we got file systems. Okay, so moving on to another interesting one here, /w. Now, /w is interesting because it's almost like an identifier in Java. If you look at an identifier in Java, what can it be? It can be any character, A to Z, any digit, underscores, and dollar signs. One thing you have to take into account, it cannot start with a digit, but the rest of it can sort of work. And we can use that to sort of work with source code. So another place where regular expressions is actually used is in source code. Trying to identify a language and make sure they've got the correct syntax, regular expressions are used there. In some degree, it's not as simple as that. If you want to know more details about that, there's an honors module called compiler construction, where you write your own compiler. You can find out about how to do that and what it means to work with that regular expressions in that way. Then with quantifiers, we want to say we want to find something a certain number of times. So that's going to be important in the example we're going to use. And this is where I want to try and show you something a bit more visual to look at. So there's some examples trying to match something. And the blue there, cyan, that is trying to match those certain characters. Now, there are tools available to assist with trying to show these matches. Now, some of these tools are available online, and they are using a certain flavor of regular expressions. When I say flavor, JavaScript regular expressions are not the same thing as Java regular expressions, not the same thing as C# regular expressions. They share most of the syntax, but there are slight differences. And there are extra things that you need to take into account. So this is one site which you can use to test or look at regular expressions and try to understand how they actually work. It's called regexpal, regexpal.com. So it's one place you can look. There are things here that you can see. There's a drop down here to choose JavaScript or something else. There's some flags here. Most of the time, you don't have to worry about those things. So let's look at the example. So let me just zoom in here so we can get it nice and big. Let's look at that example where the first one here was looking at, oh, sorry, the second one there, looking at a C. Then we have the square brackets AO and then the T. C, AO, and then T. So what you can see is if you look at how this website presents itself or presents the data, it tries to tell you, when you hover over certain sections, it tries to tell you what it's trying to do. And here you can see it's looking for exactly the character capital C, because if you don't put anything in square brackets or round brackets, it means I want exactly that. So I want exactly character capital C. Then it's look at the brackets, it highlights the whole brackets. Anything in the character set, so anything in between those square brackets. And then inside of there matches an A or matches an O. So anything that matches an A or an O, not both. Only one character between those square brackets. And then the last one is exact match for lowercase t. So if I type in here something like that, you can see it highlights that word. It won't highlight if I put a capital A because I explicitly asked for lowercase. If I type in hot, you can see that highlights as well. If I type it with a lowercase c, that doesn't work because I explicitly asked for a capital letter C, uppercase C. And if I type something that has both, that also won't match because I'm only looking for one letter between C and T. So the whole point of regular expressions is to try and identify a pattern that you want to find. Let's say that I wanted to match something like this here. So then what I could do is put there, instead of just an A, I put a capital A and a lowercase a. And I could put an O and a capital O as well. So then I take care of uppercase and lowercase. If I want to take care of that as the first letter as well, then I would have to put another set of brackets for my first one. So I can handle uppercase and lowercase in that location. Does this make more sense now? Are things lighting up now? Because that's what I want to happen, is light up. Another website, and I love the name of this website, I hate regex. There's a saying in programming, if you have a problem and you try and solve it with regex, you now have two problems. So the reason why I like this website is it does similar things to the other website, regexpal. Again, there's many tools that assist with this. And no, you cannot use it during your practice, in case you're wondering. It's for your understanding, not for your programming skills. The nice thing about this website, it wraps around something that can visualize regular expressions. And what I mean by visualize, it has this nice little graph. And it will say, okay, you start on the one end. First you find a C, then you find one of A or O, and then you find a T. If you go and read a string of characters and that happens, then you have a match. If it doesn't, you don't have a match. Now, obviously, this is a very simple one. We're going to look at a more complex one. Okay, and that's where we sort of came to this example of looking at a regular expression for a date. Now, obviously, I am not Mr. Satungu, and Mr. Satungu is not me. I explain things a bit differently, so I want to explain my view as well, to try and make sense of why we need to do certain things. So in this set of dates over here, there are some dates that are totally incorrect. And we need to identify why we need to write an expression that will not match those dates. So looking at a date in a certain format, so I need Notepad++, just give me a second. So if we look at a date in a certain format, let's say we're going to do the date in the format of year, month, day, and that's what we want. What's the simplest regular expression I can write that will match a date in that format? What's the first thing I need? All these are going to be numbers. We assume everything is numbers. And no, we're not American where we swap things around. We do it in this way. So what's the first thing we need? The year. What's the year? 4 digits. So how do I do a digit? /D is shorthand for 0 to 9. That's what it's shorthand for. So that's fine. We can use /D. How many do I want of those? I want 4. Okay, what do I want next? Now, sometimes you can write dates like this. Sometimes you can write them like this. So we're not going to worry too much about the separator there, but we can handle both cases by doing something like that. We'll handle both the dash and the slash. Now, you do need to write a bit of extra regular expressions to make sure they're both dashes or both slashes, but we're not going to worry too much about that now. That makes things a lot more complicated. So what comes next? The month. And again, we're using numbers, so what should come next? 2 numbers. Okay, seems simple enough. And the last 2, I need 2 numbers as well. I'm done. My regular expression is complete. Who's not happy? Why? It works. It works. This is how students come and complain about marks with me. It works. Okay, it works. Go test it. So again, slashes, because of, like I said, different flavors of JavaScript won't work there, but fine, let's assume that's okay. So if I enter today's date, match, win, awesome. Let's enter a date in the past. Okay, match also. All seems good, right? Year 0. Okay, maybe we let one slide. It's fine. That one's okay. Otherwise, we're going to have a very long regex. What about while a computer starts from index 0, most humans don't start on index 0. Calendars start month 1, day 1. So that's our first problem. Can't have double zeros. What's the next problem? '99th month and the 99th day. That's also another problem. I can't have 99th month and I can't have a 99th day. So we can't just keep it plain and simple and just say that I want zeros or 9s. I can't use /D for everything. We'll assume fine for the year. We'll make that sacrifice for now, otherwise we're going to spend a long time doing that one. But for the rest of them, we can do something about it. February is still going to be a pain. Something that we're not going to solve in regex because we can solve it in code much easier than we can solve it in regex. So we're going to make a couple of assumptions for our regular expression. 1 to 12, that's the valid months. 1 to 31, the valid days. We're not going to worry about 30, 31, 29, 28. We're not going to worry about that. But we are going to check the rest of them that they match correctly. And that leads us to how we get to a regular expression like the one you see here. So I'm going to have a look at just the middle section in this. That is looking at, oops, wrong one. So we're just going to have a look at the middle section here. And what we're trying to do with that middle section, let's just look at it by itself. Let's take out everything else. Let's just look at it by itself. So the square brackets, sorry, round brackets are there is to group the whole thing together. Just to say this is the month that we're looking at. So that's why we have the round brackets there. Then we have an or in the middle. So we're either going to do the left side or the right side of that bar symbol, the or symbol in the middle. And what we're saying is, if the first digit is a 0, if the first digit is a 0, the digit that comes afterwards is 1 to 9. Does that make sense? Let's see what it's trying to look at. The first digit is 0, the next one can be 1. First digit is 0, next one can be 2. First digit is 0, etc., etc., etc. First digit is 0, last one is 9. Then we got all the months from 1 to 9. Then we need to handle the next case. If the first digit is 1, the next digit can only be 0, 1, and 2. Because if we put 13, 13 months doesn't make sense. It can only be 0, 1, or 2. So if we break this up, this part is handling this case, and this part is handling this case. Does that make sense? We want to make sure that our months don't go less than 0, 1 or greater than 1, 2. Then we apply the same thing to day. And again, if the first character, sorry, I forgot my round brackets. If the first character is 0, the next character must be 1 to 9. So again, it's that 0, 1, 0, 2, 0, 9. And then, because we're working with 10s and 20s, all of them, we can combine the next part together. We say the first character can either be 1 or 2. So if the first character is a 1, the next character can be 0 to 9. So it can be 0 up until 9, and then the first character could be 2, 0 up until 2, 9. That handles our 10s and 20s. And then for 30, we're only left with a few options. It can only be 30 or 31. So there, in the last part, it's 3 and then either a 0, so 30, or 3 and then a 1. Does that make sense? Are you smiling underneath the mask? I can't see. So this is what we do when we look at regular expressions. We try and find the one that fits the best, that gives us the most accurate thing for what we want. Obviously, it doesn't take care of things like February. Could you write a regular expression that does that? Yes, you could. Will you go insane trying to? Probably as well. It'll be a lot longer than the one that's shown in an example in the slides. And speaking about interesting regular expressions, So emails are interesting. The email format is an interesting thing, the way you write out an email address. There's a standard that governs how these things work. So I'm not sure which one will give us the right one that I'm looking for. Nope, that's not the one I'm looking for. Yeah, that's the one I'm looking for. So this graph that you saw here, this nice little small graph, that's one example for something for email addresses. And that's not the full list. This is just one example of something that matches 99% of email addresses. And you can see it looks very complicated. And that's because it is very complicated. So let's have a look at something that we did, which was our regular expression for our date. And let's go have a look at that in this graph format. So there you can see there's the starting point. It says digit, and then loop back 3 times. So the first digit, and then 3 more. Then it's one of the slashes, a dash. Then we have the first group, which is our month. Now groups can get more complicated. We're just doing it as simple things. But there you can see if it's a 0, followed by 1 or 9. Otherwise, if it's a 1, it will be 0, 1, or 2. Then again, we go to our separator, slash or dash. Then we go to group 2, which is then our day. And there you can see the different sections again. The first one there being the 0, 1 to 9. The second one, either 1 or 2, because we're entering 10s and 20s, 0 to 9, and then 3, 0, or 1. So you can use this to try and see if your regular expressions do make sense. If you're missing something, if part of it is matched and the other part is not, you can use something like this to help you, assist you, to build your understanding of regular expressions. All right, so in terms of what happens with the code, so this is the code in the slide now inside of Eclipse. And there you can see at the top, we have on line 6 an array of dates being declared and initialized to an array. So it's an implicit initialization. I have to say the size of array so and so. This is trying to combine initialization and declaration into one go. So I have an array of dates, and those are all potential dates. Some of them are not valid. So you can see there is some that are valid. There's something that's not valid. 32nd day. There'll be one which has too many digits for a month. There's a month that's also invalid. And there's some cases where things might look correct, but are not correct. So if you look at this last date, for example, what's wrong with that date? Is there something wrong? There's an O instead of a 0. This is a capital O and not a 0. Now it's more clear now that you see it. It's more clear if you're using a monospace font. Usually when we write code with a monospace font. Usually the zeros and the capital O's have some sort of distinction. Usually there's a slash in the 0, so you know it's a 0 instead of a capital O. But if someone is writing this out by hand, their O and 0 might not have a slash between them. So that's something to think about. Should we allow it, or shouldn't we allow it? Now, if I'm trying to process this and put this into a database or a file or something like that, it needs to be accurate. I probably don't want a capital O in the place of a 0. But if I'm analyzing text, and I need to find all the potential dates that could be in there, my software that reads human handwriting and tries to identify is this is 0 or O might make a mistake and need to counter that. So there's different circumstances where you would accept it and would not accept it. For our application, most of the time, if it doesn't match, we don't want it. Oh, so the dash symbols that you type out, that's on your keyboard, that you type dash, that's a normal dash. That's what you see in the code here. There is something called an EM dash and an EN dash. So EN, EM, that's used in typography, in writing, in newspapers, in printed media and stuff. So with PDF files, that can happen where the actual dash there looks like a normal dash, but it's a different type of dash. And if you copy paste that, some people got an error with it. I got an error with it in the practical lecture last week when I copy pasted it. So you need to see that specific thing. If that's the case, just delete it from your code and type a dash on your keyboard and that should work. You can't really see the difference with this font. There might be a font that will show you the difference, but most of the time they don't. Okay, so with our string of dates, what we want to do is take our regular expression pattern and test each date against the pattern. Now, if the date matches, we'll say it's good. If it doesn't, we'll say no match. That's what we want to do. So there's obviously some classes we need to take into account. There's some syntactical changes that we need to take into account as well when we're working with the regular expressions inside of a Java string. Because of backslash and how backslash is understood by the Java compiler, there's extra things we need to do there. There was a question? So we don't need to escape the dash if it's in the square brackets without anything else. But if you're using it as part of the character class, so for example, here where we got the 0-9, that's being used between two symbols, therefore we don't have to escape it. So escaping is only for things that are not being used as you want, as you would be using them in the syntax itself. So like if you wanted to type a square bracket as part of your syntax, you'd have to escape the square bracket. So put a slash before the square bracket to actually make it work. So it's a good idea when you write out your regular expression, put it in a comment, as you would a real regular expression that you see wrote out in something like regexpel or you wrote out by hand. Write it in a comment, because those slashes doesn't matter which order they are in, doesn't matter anything like that, it's in a comment. When you need to put it into a string, anytime you have a single backslash in your regular expression, you have to put a double backslash in a Java string. And that's because of how Java reads backslashes in strings. It's a requirement. If you leave it out, then the compiler will complain. You can see that it's got a red squiggly saying there's something wrong. Okay, so in order to get the regular expression to work inside of Java, we have something called a pattern. So we provide it with a regular expression pattern, and we will create a pattern object. Now there is no constructor for pattern. You have to use a static method called compile. So here you can see there's the method function called compile, and it's available in that pattern class, and it takes a string which represents your regular expression and returns an instance of the pattern. So this is how what we will use to start testing the things. But in order to test, we need to do one more step. So here on line 20, we're iterating through the dates. We're getting a matcher instance using our pattern against our date. So you have a pattern, test it against a string. Pattern, test it against a string. Pattern, test it against a string. Matcher can do more than just match the whole string. It can match parts as well. For our purposes, we're going to try and keep it simple. We'll match the whole thing in one go. So here we call the matches method. So does this pattern match your string 100%? If it does, it returns true. and we can print out it matches, otherwise it doesn't match, and we print out it doesn't match. So we can run this, and then you can see there's the strings that are correct, and the ones in the error stream are in red, and those aren't correct. So you can see there, that was 13 months, that was 32nd month, that had an O again, that had some characters as a year, 00 as a month, so on and so forth. You can see all the problems there and the ones that match. So you can identify what is good and what is not. Now, after going through all of that, obviously I don't have enough time to go through all the rest of the things I need to, but what we can talk about is file handling. So I was going to write this class from scratch, but we don't have time for that. So let's cheat. Okay, so some things changed with the student class. I made the not the student class, the rest of the classes, I actually fill them in. So now for a degree, we have code, name, duration, student array with an index, module array with an index. Someone is asking about array list. If you used vectors back in C++, you had to understand something first before you understood how to do vectors, and that was templates. Do you remember templates? Was templates easy to work with? Have you learned Java's version of templates yet? No. Therefore, you're not using ArrayList. ArrayList works on the concept of generics, which is the equivalent of templates in C++. You haven't learned it, therefore we're not using it yet. And you can see I'm not using it in my code or in the solutions either. So this just creates a degree with the useful information. When it registers a student, it checks if the student is in the actual list already, array already, and then if it isn't, it can go into the thing. We make sure we resize the array as needed. You can do this manually, or you can use Java util arrays to make a copy that's double the size. Why is it double the size? You'll find out that reason in Computer Science 3A. Then if we register a student, we register the student for every module in that degree. For a module, very simple here. Also, we have an array of students, and we also have an array of lecturers who are responsible for that module. If we register a lecturer, we do the same kind of test. Are they in the array already? Okay, they're not. Is the array big enough? Okay, it's big enough. It's fine. Add it. Not big enough. Make it bigger. Same thing goes for the student. Add it, copy it. You can see the code looks very similar, except we're working with the different arrays in those situations. And then the access and mutator methods available as normal. Lecturer just has staff number instead of student number, and has an extra thing for a qualification. Sort of to separate it out. We'll try and make this a bit better when we get to advanced object orientation. And then in the main, what we were going to do from scratch, which I won't be able to do all right now, but I will show you simple code, is we have a file that can store this information. Can we use the file to populate everything we need? Can we use it to create a degree, populate the degree with modules, populate the modules with students? Can we do all of that? Answer is obviously yes, because I've already written the code for it. But there's some helper methods here. There's a method to display a degree. So at this point in time, we don't have means of doing toString, of converting an instance to a string representation. We're going to do that when we get to advanced object orientation. But long story short, what happens here is we just get some information of the degree, namely the name, the code, the duration, and the count of the number of students. And then for the modules that are available in that degree, we output some information about that specific degree. And there's a method down here, function down here to count the number of things in an array. So let's go look at the thing that we really want to look at, which is how do we handle files? So the idea or the concept we're going to be using when we handle files is we're going to do everything through static methods, because we shouldn't have to create an instance or something to handle a specific file. We can do that approach. We are not doing that approach. We are doing something a bit different. And with that, you'll see that there'll be a specific file handler class. Now, you would have seen that we have a sub-package called model, where all your model classes go. That's data classes. It stores data about your system. We have another sub-package called file. What do you think that does? Has all the classes that handle files. We have another one called GUI or UI, depending on what I feel like when I type out the practical. It might be GUI or it might be UI. That will handle your user interface. All the classes for your user interface will go into that specific sub-package. There's another sub-package called test, where you're supposed to write unit tests. And that's a topic I really want to discuss, but sometimes we don't get to that. It's not part of the module outcomes, but it's something that you will be doing when you get into industry. Well, so the question is, what's the difference between a file and a directory? Depends who you're asking. If you're asking a human being, a directory is a place to organize files or other directories. If you ask the operating system, no difference. When you get to Computer Science 3B, you learn about operating systems, and you learn about why that is the case. All right, so 5 minutes left. Let's go have a look at your class here. Now, obviously, there's a lot of things to go through. I can't go through everything, but you can see a couple of things. There's patterns for matching certain things in our text files. Sound familiar? Practical 2, sound familiar? So here you can see there's patterns for certain things. So there's a pattern for the degree file, there's a pattern for the module file, there's a pattern for a lecturer, there's a pattern for a student. Now, for students, we'll take into account that they're going to start with a certain student number, and then start with a certain year, and then have 5 digits afterwards. And then they'll have things like first name, middle name, last name, gender. Then inside of the actual static method, you can see we take a file handle as a parameter. Where do we get this file handle from? From our main. So the main gives us a file. Where is this file? The file is in the data folder. Which file do we want? That text file there. We can confirm that it's in there by checking our data folder. And you can see there are a few files there. So we look at BSc-IT01. You can see there's the name of the degree code, duration, and then some modules there. Each of those, in this case here, correspond to a file name for that specific module. And if you look at that module, you can see there's the module code, and then the information inside of there where we have some student information. So we want to read this to make sure it's all correct. We have to test and see, is this a staff member or a student? So staff members start with 1320 instead of 2013. That's the convention we'll use here for indicating staff member. And then the rest of them just follow afterwards. There might be a case where the information between these files is duplicated, but that's something that you would handle with a database. We're not discussing databases here. So you can see there is some duplicated information between the things. You'll notice that the math class is a lot smaller than the other ones, but we can try and read these files. How do we actually read the files? We're going to use a scanner, and the scanner will read a line of the file at a time using next line. Just like you do with the scanner class with reading system in, you can use the scanner class to read a file. We have to do a try catch, because if you look at here, the scanner constructor, it throws file not found exception. So we have to do that. It's a checked exception. If I try and do this without a try catch block, the compiler will complain and say unhandled exception. The compiler is complaining. You cannot compile this code until you handle that exception. So that's what is checked exceptions. The compiler is complaining. You can't even get your code to run. However, if you do, then you can get your code to run. Now, all of this here is to handle the file. There's the string tokenizer, which we talked about before, breaking up a line into multiple tokens. What are we using as a separator? A tab. So in our files, there's a tab character between each element here. So that's how we can break it up into different pieces. And the rest of the code is just going through and checking that we get all the stuff. So what you'll see here is there's a method to read a degree from a file. And because of the way the files are formatted, there's a way to read a module from a file as well. Because we have one which represents a degree, we have one that represents a module. So we can read a module by itself, or we can read a degree, and the degree will read the other modules. So your practical won't be as complicated yet, but something very similar. Then there's some extra helper methods just to take a line and break it into tokens instead of shoving everything into one method, try and break it up. You'll notice here it's declared as private because we only want this class to have access to those specific methods. Okay, so as I mentioned at the beginning, I would not be able to get through everything. I still have to show you examples of throws in your own methods and catch and throw in your own methods. That will have to wait until next week. If you have any questions, I'll be here in the front for a few minutes. Otherwise, I'll see you all next week. So I have a question about should probably turn that on first. So difference between a handler, file handle, and a scanner. File handle just gives us access to a file. Scanner allows us to work with a file. When will we start using user input for practicals? We're going to do our user input through graphical user interfaces, so nothing will be using system in just yet. Am I going to upload the code? No, because then everyone copies that for the practical. So the answer for uploading tutorial code is always a no. You have the recording, you can always go back and look at the code. We start with JavaFX, you can see that in the learning guide. Okay, any other questions that you have, you can direct to Discord.